In this tutorial, we're going to go ahead and optimize for minimum volatility and maximum Sharpe using Python, specifically the PyPortfolioOpt package. Now you can see here we installed it and we used capture just to minimize the output. And we also used yfinance for data. Now here you can see we're using EfficientFrontier, CovarianceShrinkage, and mean historical return, all from these different modules within PyPortfolioOpt. So in the next line, we define tickers and our data download, and it's just going back a year. And we also just index for the close. Now, the first thing we're going to do here is we're going to define our mu as mean historical return, which is already writing out for us. And we're also going to define our S, which is covariance shrinkage, and we're going to pass through data, and we're going to use the Leduc-Wolf method. Now, to view both these variables, we'll do them individually. Mu is just going to be our expected return for each asset, and S is going to be our covariance matrix, as you can see here. Now, when using this package, the first thing you're going to have to do is just define the portfolio. So we're going to do EfficientFrontier, and we're going to pass through mu, s, and that's all we'll do for now. We could run this, and now we could see what this EF variable is. We could see it's this object here. From here, we could simply do ef.min_volatility, and then we could run that. Now you can see it returns us this dictionary, which is just the weights of the minimum volatility portfolio. We could then store these weights in ef.clean_weights and run that. And now what we're going to do is we're going to do print weights, and we're writing a print statement so we can return two things within a singular block, considering it's a notebook. And we're going to do ef.portfolio_performance verbose equals true. We could run this, and now we can see it's going to return our weights of each asset rounded to 4 decimals. And it's also going to give us an expected annual return of the portfolio, an annual volatility, and your Sharpe ratio. Now what we'll do for maximum Sharpe is we'll highlight all of this, Control-C, Control-V, and we'll paste it down here. Now all we have to change is this right here, and we can just change this to max_Sharpe. Simply run this again, and now we have our max Sharpe portfolio. Now you can see it returns us this. Separate weightings from this optimization, as it's completely different, and this is optimizing for specifically Sharpe, so you can see we get a much higher return and a much higher Sharpe ratio. Now you can see here we did invest 0 in some of these assets. We could do add.constraint, which I'll cover in another tutorial. But for now, we're going to go with this. You can see the output's really clean and intuitive, and it only really takes a few lines of code. In the future, we're going to be going over more in-depth versions of this, but for now, we're going to stay with this, and I hope that helps.